So, hello everybody. Still energized?
Yes.
All right, awesome. Well, great. We're going to give you a use case that we want to pronounce. The city of Amsterdam, and then placed on AKS, the Kubernetes distribution of Azure. And the things we have learned, the things we want to share, and just that it just isn't enabling AKS by itself, but you must do more on that. First of all, introduction. My name is Dinant. I've recently become MVP last month. And doing a lot of innovations, technology, everything with Azure, but also doing some cycling, running, squash, and that kind of stuff. At the moment, I'm being contracted by myself, and I've been contracted by Spark, which has the contract with the city of Amsterdam.
Yeah, welcome everybody. My name is Jurgen Allewijn. I work for Luminous as a cloud architect, and I'm the lead architect for the cloud platform within the city of Amsterdam. My hobbies, you can read them on the screen, and also my LinkedIn code and so on. So let's start with the more interesting stuff. The organization. Amsterdam is a big organization, bigger than most people would expect. It's almost an enterprise size-wise. There are a lot of challenges there. If you look at the company, you see here the structure. We have 50 departments. One of the departments is IT, and that's split up in several other departments. We work for the department which is called Digitale Voorzieningen, and that's basically the department that provides structures like public cloud, but also hosting, connectivity, and all kinds of other stuff, workspace also. It's a big organization, and this is only the people who work there, but there's also, of course, the political side. So we have something like the council, the city council, we have the mayor, so we have a lot of influences which we have to take into account in everything which we do. When we started with building the shared AKS solution, we had to take into account a lot of stuff. So, it should be efficient, make efficient use of the resources, because we don't want to pay that much money to Microsoft, because we want to give it to it's public money, so we want to do it also for street improvement and all other things within the city. So that's more important than spending it on IT. But it should be reliable, it should be safe, because we process data of the citizens of Amsterdam and the companies, so it should be safe. We want to have it in a modern IT environment, and we want to link it to our data platform, which is also running on Azure. And it should be future-proof, so it's not something that we define for now, but it should be running for more time. We started in 2019 with the cloud strategy, and we chose Azure, like a lot of cities basically, and we chose for SaaS before PaaS, before IaaS. It's also a very common strategy, and we said that we use Azure as our PaaS platform, and also the thing is that we can only use general available features. That's also important for this talk, because a lot of Microsoft features are in public preview, but because of all kinds of political and law reasons, we are not allowed to use public preview, at least not in production. And the other thing that we wanted to do is everything as infra as code, so that as code, you can run it again, and you are not depending on the knowledge of people, what they did, and but that you can run it again, and you know that it's the same outcome every time you run it. When we started with the cloud platform, we also defined a lot of principles which workloads have to comply to work on our platform. But we ourselves also have to comply to those architectural designs. Makes it a bit difficult. I'm not going to tell them all, but some of them, like you build it, you run it, you own it, self-service within 5 minutes, everything is code. Yeah, that are very important principles. And we have to be compliant with a lot of networks or frameworks, like NORA, BIO, Security Control Framework, to name a few. So this is a quite list of measures we have to take into account when we design an environment.
So then the question is, like, what is shared AKS? Yeah. In our opinion, of course. Well, first of all, we want to share some challenges we faced, looking to workload teams, looking to costs, compliancy, as you mentioned, but also technical issues. But first of all, the workload teams. So most of them on our side, they do have a lot of knowledge. They can do a lot of things. But Kubernetes by itself, it's quite a hard technology to manage. Also, they want to change their way of work because we are on DevOps days, right? So everything must be on a DevOps way, repeatable and very fast. And of course, the newest technology in hand grasps. Looking to the cost perspective, I think this is already being touched a lot of times today and yesterday, but everyone wants to save costs as possible. But it should be, of course, up-to-date, automatic, and also being done with the compliancy standards, as Jurgen is mentioning. Looking on the technical side, the most problem I think we faced is the multi-tenancy, right? Yeah. AKS, or I should say Kubernetes by itself, everything is an open unless strategy. And since we are dealing with a lot of information which is protected, we have to divide all those workload teams from that. So that's a lot of things. We also faced a lot of public previews, as Jurgen already mentioned. Nowadays there is a lot of in GA, general available, which means we have support from Microsoft. But then the problem came with a lot of private endpoints. So we had a new struggle again. Looking to the plan of action. So from the architecture perspective.
Yeah. So from our architecture perspective, when we started with the design, we took into account the cloud adoption framework from Microsoft. We also took into account the well-architected framework, which is a set of rules how you should design a solution divided around 5 pillars. So not something only Azure does, also AWS and Google also have a well-architected framework. So that's one of our bases. We needed to be Haven compliant, and Haven is a standard which is thought of by the Vereniging Nederlandse Gemeenten, and it describes how a Kubernetes environment should be compliant. But if you run that, basically, it's not that strongly protected. It's easily to hack if you only have our Haven compliant. We also have the BIO, and you see here BBN2. That's the level within the BIO. You have BBN1, which is publicly available data. BBN2 is data that's traceable to somebody or some organization. And BBN3, and that's the secrets for state. And the city has no state secrets, so we don't have BBN3. So our platform is BBN2 compliant. Yeah, and what I think is nice is that when we had the platform up and running, we did the well-architected review by Microsoft, and we scored 91% compliance, and that's very high even within Microsoft. So we're kind of proud about that. Thank you.
Yeah, it was quite amazing. They said also, like, we almost never seen that high score. So I think we are doing a good job with each other. Looking from design perspective, I don't know if it's readable, it's quite a lot. I don't ask you to read everything, just some highlights. Looking to AKS side perspective, everything should be secured. So a private AKS cluster, it's just a no-brainer. The elements that we just want to touch is the workload separation based on agent pool concept, meaning that you can label your Kubernetes worker nodes with labels or tags, stains, and on that way you can separate your workloads basically on a few agent pools by themselves. We have chosen 3 of them, so in each availability zone of Azure you have the protection from there against outages. Another element that you want to touch is the Nginx controller, the way you can expose your applications to the public. Normally Microsoft is advising the AGIC, the Application Gateway Ingress Controller, a mouthful, and we have chosen Nginx because it was not stable at that time.
And also it's now depreciated because it will be replaced by a different product because they saw themselves that it's not stable. So. And the new product will be based on Nginx.
So I think we have seen it at forehand maybe. Looking to the other components, a shared ACR, meaning that we have a DTAP environment for specific AKS clusters, and just one ACR to share your images between those 4 environments. Workload identity, one of the elements that is just announced general preview since 2 weeks, is a way to make Kubernetes communicate to Azure AD.
General available, you mean?
Yes.
You said preview.
My apologies. General available, which means that you can authorize your Kubernetes applications to Azure AD. So that's quite amazing as well. Furthermore, Cured is a component that we're using in the Kubernetes update daemon set. Also a mouthful, but meaning that you can update your Kubernetes worker nodes automatically. And one element is also the container security, which should be a Defender for Cloud, but at the moment we have chose Aqua Enterprise. In that way, because we want to give the users also the possibility to have a separate screen for all their workloads by themselves. And that part Defender for Cloud could not offer to us easily. So we have chosen that part as a replacement. Looking to the other components, the compliancy stuff, it was quite a lot. I think we have investigated quite a lot of time on those components. But just to give you a glance, SIS is a way to protect your Kubernetes worker nodes. You have them in Kubernetes, on Ubuntu. As Jurgen already said, the Azure Security Benchmarks is the way that Microsoft gives guidelines to that. And we have, of course, a lot of Azure policies. So a lot of policies that are available, making the protection possible on also the components that we didn't touch on that. So that's quite easy, and on that way we can also manage it over all the clusters all together. So that's quite cool. Looking to the solution, what is it then, what we have built? So maybe a difficult picture to understand, but basically we have created 4 AKS clusters. Each team gets its own agent pool, and on that agent pool we have a sort of limitation enabled. They have 251 IP addresses available to make their pods, their applications. Most teams do have around 1 or 30 applications, so that should be fine. If they are exceeding, and that's just also possible, they can get a bigger network size, making a 521 if they need to. Scaling is also enabled, so if they have applications that want to scale because it is required, they can do so. They can do it horizontally and vertically. And one of the elements that we want to touch in the near future is SCADA, which is also touched, I think, yesterday. A way that you can simulate your scaling based on events. So that's quite amazing. A workload team works in its own subscription that we are doing based on the fact that they have to pay for their resources. So the agent pool is labeled with their own tag and the resources that they want to provide, for example, databases that they need for the applications they can connect to. Also the key vault for certificates, for example, of storage, persistent storage. And those network traffic rules, those are automated away. If the workload teams can tell that to us, which traffic flows are required, we can provision that away in a way fully automatically. Looking to the workload teams, what do they get then? First of all, an agent pool, which can be sized differently. Some people require more CPU, others require more RAM or maybe less because it's a POC. So we can divide basically on the VM size. It's quite amazing. The namespaces they have to offer to us. So we are creating the namespace, meaning that they're getting a service account, and on that service account, it's a little bit technical now, but if they are using the service account, they can provision everything into the namespace without needing admin access at all. So they can just do their job. So on that way, we don't have to take into account if they have too many permissions on that part. On the front end, you see the application gateway. I've shortened it like the app gateway. So in that way, if we know which URLs they want to provision to the outside world or the internal world, within Azure or on the express route on the data center sizes, we have two separate traffic flows. Also two separate engine access to make all the traffic being divided on that part. And then to troubleshoot purposes, so that the kubectl config file is not being placed on all local devices, we have created a sort of AVD solution or another solution to just give remote access to see kubectl logs, for instances, to see if the containers are healthy or being broke and what to do about it.
Yeah, after we deployed everything, we of course have a lot of lessons learned, and I think that's the most important in every project, the lessons learned. Yeah, we have divided them in business, security, and technical lessons. Business lessons and security lessons first. Yeah, it's nice if you deploy a platform, and it's a really cool platform, I think, from a technical point of view. And it offers a lot of features, but how do you convince the people who are going to use it how to use it and how to implement it? And that's difficult, because they are working in a more traditional way, and they have to do the mind shift to work in containers and in the DevOps way, and also think cloud native, and that's a difficult challenge. And I think as a city we underestimated that. We're now fixing that by giving training and giving support to the teams that are moving to our environment. But at first the adoption was not that great because of the knowledge gap. And I think there are a lot of companies who use Kubernetes struggle, because Kubernetes sounds cool to use, but you can also make a lot of mistakes and make it very difficult. So I think that's for us was an eye-opener, and we just organized a hackathon with the teams, which Dinant amongst others organized, and we had a good session with the teams, and then we took them on the road in deploying the first pipeline or the first application, so they get the knowledge. And also because it was a hackathon with more teams, you get the added value that you can ask other people who have the same problem. How do you solve this problem? How do you look at this issue?
Basically, just to be hands-on and just do it with each other, right? And two members are in the room, so I think they can approve about that.
Yeah, somewhere behind in the middle. Also, a lot of security. lessons. Yeah, we had to implement a lot of frameworks, and it makes it difficult because they interfere sometimes with the normal operation of Kubernetes. So you have to find workarounds. Also, what I said earlier about the public preview versus the general available. Sometimes we had to choose a solution because the public preview was the only solution, just we had to create a workaround. For instance, the workload identity, which was mentioned earlier, that was when we started, it was in public preview. The predecessor pod identity was depreciated. We were not allowed to use depreciated and not allowed to use public preview. What do you use? So those kinds of discussions, and that makes it very difficult to have a good security implementation. And also, we didn't want our cluster to be available from the outside. So we use private endpoints, and that also makes it more difficult because not all options within Azure support private endpoints. Technical, how do you create a multi-tenant environment in a solution that's basically designed to be single-tenant? And how do you separate it in a way that workloads can't see the other workloads? So we did a lot of thinking, and during our design process, agent pools became available, and GA, so there we had a solution. But before that, we had a lot of discussions, how are we going to separate that without spending too much money, because you can create separation, but then you don't have the value which you create of a shared cluster, because then you have basically to deploy all single clusters. Kubernetes is difficult. It sounds easy, AKS also easy, it's a PaaS service, so it's just next, finish, and it's there. Yeah, maybe it's there, but then it really starts. Then you have to do all the tools, the configuration, and all the other stuff to get a safe working environment. So it's maybe a lot of people underestimate the value that a PaaS service like AKS or EKS or GKS or all managed Kubernetes service offer in basic. You have to do a lot more to get a good working system.
I also think that we also wanted to give our users the possibility to just not being confused about the Kubernetes elements that are under the hood, and they're just getting some pipelines just to push into the namespaces so that they can basically focus on the applications instead of the technology behind it.
Yeah, that was our main idea. Maybe we have should have told that at the start. We want to offer almost all freedom to teams that they can do their work, but within the guardrails that's the security frameworks which are in place. How would you say?
Definitely. So if anyone is interested in the jobs behind it, I have also written a lot of vlogs that is posted on the slide. So if you like it to deep dive into that, there you can find the links.
And also the links to the projects where you see the updates for AKS and ACR, because there are a lot of updates every month, basically.
Yeah, we have a lot of conversation with Microsoft together with the product teams.
Yeah. Takeaways, I think most of them are mentioned already. It's difficult. You have to really think and design. You have to keep the value you want to offer. That should be your point on the horizon. Where are you? What's your goal? What do you want to achieve with the designing of the solution? I think that's important to have that clear up front.
Exactly, yeah, definitely reducing costs by sharing, right? I mean, everything is expensive, and just make it easier for your users. That's basically the main purpose and takeaway. So, thank you for having us.